Okay guys, welcome to day 6 of the Advent of Code. So, where we are today is we're in this manufacturing lab, and we've got the guard, which is represented by this position. And what the guard does, is the guard patrols the lab, and the guard will just keep going forwards, then until it hits a wall, and then it's going to turn right, and so on. And when the guard leaves, which we can see down here. When the guard has a clear path to go off the board, the guard just goes off the board, and then the lab is now empty. And what they want to know is they want to know how many positions is the guard going to visit. So I don't know. Maybe they want to. Maybe they're going to use this to calculate time or something, or maybe they want to know where they can safely go without the guard coming to see them. But that's irrelevant to us. All we need to do is provide the value. So let's take a look at the implementation. So here we are in the IDE. This challenge I found pretty difficult, but we were starting off in a positive frame of mind. We were using some idiomatic features. We used the derive macro. We used some implementations, some traits, and some structs. So we created a point vec struct. That just means it could be a point or a vector, and we created some logic to add them. We just said that we created a get function for the grid to safely get stuff and return none if we try and get something out of bounds. Just so that we don't have to, just to make error handling a bit nicer, I guess. Then I'm gonna need to go through how we model the coordinate space in this. So what we do is we say the top right is 0, 0. So this, as you can imagine, messes with your traditional understanding, which is that, we say the top left is 0, 0. Traditionally on the Cartesian plane, the bottom left would be 0, 0. So essentially we've just, if you know linear algebra, we've done a matrix transform, and what j hat is, so the up thing, is now -1, 0. Because that would be the equivalent of going up, because we're getting closer to 0. Okay. So with that bit of housekeeping out the way, where did I actually ingest? I ingested the data at the bottom. Let's start there. So there wasn't too much ingestion to do. We just created it into this vector of characters, and then we passed that into part 1 and part 2 functions. So let's take a look at part 1. So we got this directions constant up here, like I mentioned earlier. Part 1 wasn't too bad. So we say the guard location is the we just say is the top left for now, but we do actually change that. We say that the direction by default is up, because it's like the guard always goes up on his first move. So now we just find the guard. We just iterate through the whole grid. We look for the guard, and we store its location in this point here. Then we leave our loop. Then we just create a track. We just create track of visited. We keep track. Sorry, can't speak today. We keep track of visited positions in this hash set here. And we insert the guard's starting position, because in the actual text of the challenge they said they wanted us to count that in the number of positions that it visits. So then we just iterate through the loop, and we just do what the guard would do. So we say that the next position is the guard's location plus the guard direction. So that this is just me kind of being a bit unmathematical and just saying that we can add a vector to a point, and that gives us a new point. If this was a bigger code base, if it was actually game or something, I might have had separate points and separate vectors, and actually said that, okay, you can only add a vector to a point, you can't add a point to a vector and stuff like that, but that's redundant. Then I even use a match thing, very idiomatic today. So we get, using our get function that we implemented up there, we get the next position, and we just say that if the next position is a dot, so the guard can move there. Then the guard does move there, and we insert the location that the guard now is into our hash set. And then we say that if the next position is a wall, which is represented by a hashtag, then we do this, which means that we turn right, or essentially we go on to the next vector. And then if we get nothing, so if we're out of bounds, then we break the loop, because in this case means that the guard's gone off the board, so now we don't care, the guard's gone out of the range that we care about. And this bit here is just in case in the impossibility that we got the sum and some other character, which can't actually happen. But that was just to make the compiler shut up, because I was feeling pretty tired when I was writing this. So there, yeah, then we just return our visited positions.length, and that will be what gets printed here. Okay, so part one, pretty simple. Part one you can actually do pretty simply just by looking at your input data set. I got a bit carried away trying to do that, but I decided it wasn't worth it just to count. And it was lucky I did, because if we take a look at part two is an absolute pain. What they want to do is they think they can't search the lab without getting caught, because the patrol area is too big. So they can add a single new obstruction, and they want to place this obstruction in such a way that the guard is going to get stuck in a loop, making the rest of the lab safe to search. And they want to know all the possible positions, but you can't place it at the starting position because they'd notice. So in the example above, blah blah blah, we can place it in here to get it stuck in a loop, and so on here, to get it stuck in a loop, so on and so forth. There's loads more, but we're not going to go through them. But yeah, so it doesn't really matter. Okay, they've given a bunch of examples. Cool. Alright, and they want to know how many different positions could you choose for this obstruction. So in their example, it was 6. Alright, so I think we'll just go straight into the code. Alright. So we're cloning the grid and passing it into part 2. Nothing too bad here. We have got a vector of characters, which we don't actually need. Alright, fine. 3 performance improvements there. And we've got the grid's width. Oh no, sorry, this is the grid's height, and this would be the grid's width. We want to find the starting position, and so we just say, we keep track of, we say it's 0, 0 for now, we say found is false, and we go through this loop until we found it. Yeah, I think that's okay. Then what do we do now? We just create this directions thing. Again, I think already created it up here. But oh well. We've done it again. Then what we want to do now is to just see where it could start. In fact, no, that comment's garbage. We create a hash set to keep track of visited states, now using usize, just so that we don't have to cast as much. We set our x to our initial x and our y to our initial y. Then we loop, and we insert into visited states the starting position, because they wanted us to count that. We calculate our next x and next y, so our next position, and then what we do here is we just do a quick boundary check. We say that if they're gonna go out, then we need to break the loop. Okay, and what else do we do? We say that if they're gonna move into a wall, then we change direction, and if not, then we just go to the next position. Nothing too complex there. Now we keep track of our answer. We iterate through all of the starting x's and the starting y's. We iterate through all of those from our hash set, all of our possible starting points. And then I've created this loop exist function, this will loop, to see if we will get a loop if we can get a loop from that starting position. And if it does, we add one to the answer and return it. So let's take a look at the will loop function. So we take in a lot of parameters, start x and start y. I didn't use the point vec struct throughout this because I was having to do too much casting and it was really slowing down the performance of my code. So I just decided not to use it because I couldn't really be bothered to optimize and figure out the right type. We take in our initial x and our initial y, that should be. You know what, why don't we just change that now? Our initial x and our initial y. I was using ij before, but I changed it because it was messing with my head. If that we're starting at a wall, we're going to return false because that can't happen. We just set this to be a hashtag, to be a wall. So this is just meaning that we can't infinitely run this will loop function. This is just like an escape hatch from the loop, so we don't go on forever. We sort out our x and y values, and again our scene hash set and our direction count. We check if we've already been to the place that we currently are. And if that is true, then we undo what we did here, revert the grid back to its old state, and we return true because we did get into a loop because we've got deja vu. We've already been somewhere that we've been, and then we keep going. If that hasn't happened, then we insert the current place that we are into our hash set. Now we calculate our next position. Again, we do a quick boundary check. So if we're going outside of the bounds, then we're going to undo what we did up here. We're going to undo our escape hatch and then return false because it's not looped because we've just left the bounds of the search area. Then what we do is that if we say that, again, we do our direction change logic, and we say that we're going to change direction, we're going to turn to the right. And else we just go to our next position. So 2 layers of movement loops, essentially. And then we get out of that, we've counted up all our loops, and we get to the answer. So we just return the answer out, and we print it. And I believe that answer was 1604 or something like that. Yes, it was. So hopefully that made sense. In my opinion, at least, bit of a tricky one today. And that probably wasn't the most beautiful implementation. I may actually, in January, go through and just fully optimize all of my solutions because obviously in the real world, you care about really optimizing the performance of your solution, and it's very rare that you just get to hand off ownership of some code and never work on it again. But until day 7, I will see you later. Thank you.